Okay, everybody, welcome to part 2 of section 2.1, basics of functions. We're going to focus on the graphing part of this section. So part 1 video went with the 4 topics in black here. The blue represents the topics that we're going to be talking about today, all of them dealing with graphing and identifying functions from their graph and other information from their graph as well. If you remember functional notation, when we write y equals f of x, when we replace y with f of x, what that tells us is we automatically know we have a function. As soon as you see this notation f of x, we know we have a function, but it doesn't change the value. It still plays the role of y. It's still the dependent variable, all that kind of stuff. So when you go to graphing, the graph of a function is just the graph of its ordered pair. So where we used to plot x comma y's, now we plot x comma f of x, but so f of x is still the y variable, right? Or whatever the function is. In this case, we have a function f of x, and we also have a function g of x, whatever, right? And so the very, very basics of graphing, we don't graph this way very often, but to give you a feel for what graphing a function looks like, we are going to do it by what's known as plotting points. We're just going to pick a few numbers, integers between -2 and 2, and we're going to plug those into our functions. We're going to get y values. We're going to plot those points, okay? So this is a good time to get out some graph paper if you have some, and we're going to kind of walk through this together. So how does this work? If x equals -2, then that means we want to find f of -2. How do we do that? We plug a 2 in where the x was. So we plug a -2 in where the x was. We get 2 times -2, which is -4. Find f of -1. That's 2 times -1, which is -2. Plug in 0. You get 2 times 0, and anything times 0 is 0. All right, and so we're just taking the number x and we're plugging it in for the x in our function. 2 times 1 is 2. F of 2, 2 times 2 is 4. Okay? We're going to do the same thing with the g's. You plug in -2 for g, plug in for x. You get 2 times -2 minus 3. 2 times -2 is -4 minus 3. That gives us -7. Okay, if you want to find g of -1, same thing. Plug it in. You're going to get -2 minus 3, which is -5. G of 0, plug in 0 for x. 2 times 0 is 0. Minus 3 is -3. All right, plug in 1. 2 times 1 minus 3 is 2 minus 3, which is -1. And then finally plug in +2 for x. You get 2 times 2 minus 3, which is 4 minus 3, and that's +1. So if you take a look at the next page, then what you'll see here, I've just copied these down to make them look a little nicer. All right, here's your function values. And so what does that mean? On a graph, that means we get the point -2, -4, -1, -2, that kind of thing. And so, okay, so for both these graphs, what do we have here? Here you can see in red, -2, -4 is right here. -1, -2 is right here. 0, 0 is right there at the origin. 1, 2, 2, 4. We plot those points. We draw the red line. If you were plotting the points for G, you have -2, -7, -1, -5, 0, -3, 1, -1, of course, and then 2, 1. It's right there. And you connect the dots, you get a straight line also. Okay, so that's just the idea of how to graph, right? If you look at this, note this point right here, all right? Take a look at this point right here. This point right here is what? That's the point 4, 8. That's what that point is right there. It's on the red line. Guess what happens if you plug in 4? 2 times 4 is equal to what? 8. Yeah, 4, 8. The only way that that number, that ordered pair, can be on that graph is if it matches this equation. Right? Pick a point over here somewhere and plug it in, it won't work because it's not on the line. So that's what those are about. All right, so make sure you do some practice with that, but again, we're going to get into more specific and special types of graphing in the next couple of sections, so just know how to plot your points, just know where your x's come first, x's left and right, y's up and down, that kind of stuff. Okay? All right, so now once you have the graph given to you, there's a vertical line test for functions for graphs, okay? Because if you remember what graphs look like, and if you remember what the rule is for functions, then you'll be able to tell what's what. So if we take a look at graphs, here's a graph of a relation, here's another graph of a relation. All right, now, are these functions though? They're both relationships between x and y. Are they functions? Well, this vertical line draws down here. This vertical line intersects your curve at 2 points. What does that mean? That means for this x value, whatever this x value is, you have 2 different y's. Right? These y's are different. And what's the rule for a function? The rule for a function is if you have more than one y for the same x, you have more than one y for the same x, you are not a function. Okay, so this is said to fail the vertical line test. All right, this fails the vertical line test because it has more than one intersection point with a vertical line. It only has to happen once. If I draw a vertical line over here, I don't get any intersection. It doesn't matter. But if it ever happens, it's not a function. Whereas over here, no matter where I draw this vertical line, I'm never going to hit it at more than one place. And since I never hit it at more than one place, this is a function. It passes the vertical line test. And so it is a function. All right? So you can just take a look at those, and pretty simple. All right? And now we have to be able to look at graphs and get some information from them. So if I give you this function that represents the time after being infected by HIV and the average T cell blood count, T cell is a positive count for your blood, and so we want to find f of 5, and we want to talk about what that means. So f of 5 means what? X is equal to 5. X is the number of years after infection. If we take a look at x equal 5, we go up or down until we hit a point. Here's a point right there. What's the y value that goes with that point? 400. So f of 5 is equal to 400. What does that mean? That means after 5 years, the average T cell count in a milliliter of blood is 400 T cells. Okay, so that's how you read that off of there. Okay, so now you guys take a look at this one, same function, same graph, but now I want you to use the graph to determine which value of x gives you f of x equal 200. So pause it for a moment and take a peek and see what you get. All right, so what has to happen this time? We have to take a look at 200 as the y value. This is a y value, so on your graph you look at 200, you go over till I hit this point. What's that point? That point is 8, 200. And so that means that f of 8 would be equal to 200, or in other words, x equals 8 will give you 200 on the y value. And what that means is after 8 years of being infected, okay, then the average T cell count per milliliter of blood is 200 T cells. Okay, less, it's going down. Okay? All right, so you need to be able to read the graphs and understand what they're telling you. X is always the domain, and y is always the range of your function. So the domain, again, is equal to the x-axis, inputs. The range corresponds to the outputs, the y-axis. And so when you look at a graph, you figure out all the x's that give you points. That's your domain. You figure out all the y's that give you points. That's your range. Okay, so here's an example. Here's a short period graph. It only goes from x equal to -2 It goes all the way up to +1. There's no holes, there's no jumps, there's no gaps. So what are the x values that give you some point? The x's that give you some point are from -2 to 1. This solid circle on each end tells you that we include our endpoints and there's no gaps in the middle. We don't have to leave anybody out. And so the domain is -2 to 1, including -2 to 1. What's the range? Well, you can't go from left to right. You have to go from bottom to top now for the range. So the bottom, 0 up to a top of 3. And again, there's no jumps or holes or anything like that. And so the y values are greater than or equal to 0, less than or equal to 3, between 0 and 3, inclusive again, including the endpoints. Okay, so here's an example for you. Okay, please take a moment and hit pause, and you guys figure out what x values you get and what y values you get, and that'll give you the domain and the range. Okay, so the domain is x's starting with -2 all the way over to +1 again, but this time there's a hole in our graph at -2, so we do not include -2, but we still include +1. And so the interval notation is -2 to 1. We include the 1, hence the square bracket. We do not include the -2. That's why it's a parenthesis. Okay. How about y's? Well, again, we don't move left to right. We move bottom to top. So even though this is up here, I don't start up here. I start down here. -1 is my bottom. I move all the way up, 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 up until 2. And so I'm between -1 and 2. I include the -1 for y because this is a solid point. I do not include the 2 because that's an open circle. And so -1 to 2 is how I write my range values. All right? And so that's a skill you need to be able to do. Looking at the graph and determining the range and the domain off the graph. All right? Likewise, you should be able to determine intercepts. Remember that an x-intercept is where you cross the x-axis, a y-intercept is where you cross the y-axis. You can have more than one x-intercept, but you can never have more than one y-intercept because when you're on the y-axis, x is equal to 0. And remember, it's okay to have more than one time where y equals 0, but you can only have one time where x equals 0 because if x equals 0 more than once, then it's not a function. Okay. So for the intercepts, where do I cross the x-axis? All right, looks like I cross it 3 times at -3, at -1, and at +2. Those are your x-intercepts. Where do I cross the y-intercept down here at the blue dot? That's a -6. Easy to see. Okay. And again, a skill you should have. All right, so get yourself some practice with those, and we'll see you later.